And welcome back. Today we got the Math 3 7.2 notes. We're going to be doing more stuff with circles today. Today we are converting circles to descriptive form by completing the square. So what that means is if our equation isn't in the form that we want it to be in, we're going to put it in that form that we do want it to be in. All right, before we do that, though, a little warm up. It says identify the center and the radius of this circle here. Okay, so remember to find the center of our circle. Basically, we just want to make the squared parts equal 0. What do I have to stick in for x to make this squared part come out 0? What do I have to stick in for y to make this squared part come out 0? Okay, so for the x's, well, what plus 3 is 0? Well, negative 3. And then for the y part, what minus 2 is 0? Positive 2. So then negative 3 comma 2 is going to be the center of this circle. And then the radius is always just going to be the square root of our number on the end here. And keep in mind, it's not always going to be a perfect square. This one is the square root of 100, we just get 10. So we're going to put root 100, which equals 10. That way we know where the 10 came from. All right, now like it says down here, what happens when the equation is not perfectly set up in descriptive form, which this is descriptive form, to where we can identify everything? Because, for example, if this was multiplied out and this was multiplied out and we combine whatever like terms we had, and maybe we subtracted the 100, put on the other side. Well, can we identify the center and the radius if it's a big mess like that? No. So when it's not in this form, what we have to do is complete the square, and that's what goes in the blanks here. Complete the square. Complete the square. All right, so again, we want to complete the square if it looks something like, well, this down here. So let's take a look at example number 1. And we can probably zoom in on it a little bit. All right. So when we have something like x squared plus y squared plus 8x minus 18y plus 93 equals 0. Okay, well, it is a circle because I have x squared and y squared in my equation, and I'm adding them together. Okay, that's the important things there. That's what makes it a circle. So then what's my center going to be? What's my radius going to be? Well, we can't tell when it's in standard form like this. Standard form is just multiplied out. Okay. We want it in descriptive form, so we want to complete the square to get it in that form. So we want to do a couple things in our first step to save some writing. We're really going to do about 3 steps in one. Okay. First thing we want to do is get rid of any coefficients, any numbers that are hanging around. So the 93, we want to move that to the other side. We want to subtract 93. Okay. And then when we write this out, we want to do 2 other things as we're moving that 93 over. One, I want to group my x's and my y's terms together. So in other words, the x squared and 8x, I want to group those together. So I'm going to write those next to each other, x squared plus 8x. And then also, one thing we want to do, leave a gap here. Okay? And in fact, we can fill in the gap. What we want to put there is plus blank, because we know to complete the square, I have to add something to make this perfect square. Okay, I also want to group my y terms together. So we got a positive y squared, and then minus 18y. Oops, so I put plus. Let's cross that out, minus 18y. And then we're going to have to add something to the y's to make that a perfect square as well. And then equals, and then on the other side of the equation, we got that 93 we moved over, so negative 93. And then don't forget, since we're going to add something to the x's and add something to the y's, well, whatever I add to both sides of the, whatever I add to this side of the equation, I also need to add to this side of the equation, because it's going to need to be on both sides. All right, so put a plus blank twice on the right side of the equation. Okay, so now we got a step to do to where now we can complete the square. Okay, and then what is going to go in the blanks? Well, remember, it's always going to be half of your middle term squared. Okay, so half of 8 is positive 4. Positive 4 squared is 16. Now, as we saw in the objective 1 notes, you can write 4 squared, because then you know what goes in the binomial. Or you can put 16. It doesn't matter. It's just whatever you prefer. Half of negative 18 is negative 9. Negative 9 squared is 81. Okay, so I'm just writing the number here. On some other examples, maybe I'll put what I squared to get that number. And then since I added 16 to this side, I need to add 16 to the other side. Same with the 81, I need to add it to the other side as well. Okay? All right, and then let's see. We'll start on the left side of the equation. Well, why did we add 16 to this part here? Well, now I can write this thing as a perfect square. This is going to be x plus 4 squared. Okay, remember, what's always going to go in here with the x is whatever we squared to get 16. I squared positive 4 to get 16. Okay? And then it's plus this stuff, so we got to have a plus here, otherwise it's not a circle. And then, well, what did I square to get positive 81? Well, remember, we squared negative 9, because if this is negative, this should be a negative in your binomial. So we squared negative 9 to get positive 81. So then that's what's going to go in there with the y's. And then equals, well, whatever this stuff equals. Let's see, 81 plus 16 is 97. Minus 93 gives us 4. Okay? And then, well, when we first got our equation, what's the center and radius? I don't know, I can't tell. But now, what's our center and our radius? Our center is going to be at negative 4, 9, and our radius is going to be 2. Okay, so once we get it in descriptive form, it's easy to get the pieces that we want. Okay, now this looks like a lot of stuff here, but really this is as hard as circles can get. We had to complete the square for the x's and for the y's in order to figure out what we wanted. But this is about as hard as circles get. The only thing they can do to make this harder is maybe, give us an odd number here, so we'd end up with a fraction when we square it. Okay, but this is all circles can really do. This is as hard as they can be. All right, anyways, let's take a look at example number 2. All right, example number 2, we got x squared plus y squared minus 6x minus 40 equals 0. So what's my center? I don't know. What's my radius? I don't know. Okay, so am I going to have to complete the squares for the x's and the y's? No, not for both of them. I have x squared and x to the first, so yeah, I do need to complete the square for those, for the x's. But for the y's, well, I just have y squared and no other y to the first term. So I don't need to complete the square for the y's. I'm just going to have y squared in my equation, and that's fine. Okay. All right, so just like last time, we want to do 3 things. We'll start by adding whatever numbers here, the coefficients. We're going to add 40 to both sides. And then I want to do a couple things when I start writing out my next line. First of all, I want to group my x's together. So the x squared and the negative 6, I want to put those next to each other. And then we're going to leave a blank because we want to add something to make that a perfect square. And then we got plus y squared, which is fine by itself. And then we don't need to add a blank because we're not completing the square for those. Equals 40. And then plus whatever we're going to add to make the x's a perfect square. Okay? All right, and then what's going to go in the blank? Well, I want to take half of this number, which is negative 3, and square it, which gives me 9. Okay, and again, you can write it either way. They mean the same thing, just a different way of writing it. So then, what's going to go in the parentheses with the x here? Well, what did I square to get 9? Negative 3, it's right there. So x minus 3 quantity squared plus y squared equals 49. All right, and now we've got our equation in descriptive form, which is what we want. Now I can see that the radius is going to be at 3, 0, and my radius is going to be 7. So center 3, 0, radius 7. All right, so there's number 2. Let's go ahead and move on to number 3, which we can already see is going to have some fractions in it. And then, yeah, we got an odd number here, so probably going to have some fractions here, but we will deal with that. All right, let's take a look at number 3. All right, well, just like the last 2 problems, first thing we want to do, get rid of that extra number. So we want to add 23 over 4 to both sides. And then in our second line, again, we want to do a couple things. We want to group the x's together and group the y's together. We can see we're going to have to complete the square for both of these this time. And then we also want to leave room to add something to complete the square. All right, so we're going to have x squared minus 5x plus something, because we want to make that a perfect square. And then plus y squared plus 4y plus something, because we want to make that a perfect square as well, equals, we're going to have 23 over 4 on the other side, plus the same 2 things that we added to the left side of the equation, so plus blank and plus blank. Okay? All right, so a big long line, but now we can start filling stuff in and get this in descriptive form. All right, so let's do the y's first. Those are a little bit easier. So again, what goes in the blank? Half of my middle term squared. Half of positive 4 is positive 2 squared, gives me 4. I'm going to put that on the end here, actually. Okay, it doesn't matter which blank it goes in, but you'll see why. I just want a little extra space next to that. And then what goes in this blank? Well, again, we want half of this number. Half of negative 5 would be negative 5 over 2. and then I want to square that number. And then what's negative 5 over 2 squared? Well, square the top and square the bottom, I get positive 25 over 4. Okay? All right, let's just start on the left side of the equation. Why did we add that stuff? Well, now I can write this is something squared and this is something squared equals, this will just be some number. Okay, so what is this first squared part going to be? Well, what's going to go in here with the x's? Well, what did I square to get 25 over 4? I squared negative 5 over 2, so then that's what goes in here is negative 5 over 2, and that's the advantage to writing it like this. If I wrote 25 over 4, I'd have to factor something that was, with fractions, it'd be kind of hard to do. Okay? And plus, we have something with y in it, squared. What's going to go in here with the y? Well, what did I square to get 4? Well, we squared positive 2, so then plus 2 goes in there. And then equals, well, how do I add up these things? Well, since these are fractions, I want to write this as a fraction as well. So then instead of 4, let's kind of, cross that out. Let's write 4 as 16 over 4. Because then it still equals 4, but now we have that common denominator of 4. Okay? And then when I add all these together, let's see, 23 plus 25, we get 48, plus 16, we get 64. Divided by 4 gives us just 16, so that worked out nice, came out to be a whole number. In fact, it's also a perfect square. So now I can see that my center is going to be a positive 5 over 2, comma, negative 2. So that's 5 over 2 is just 2.5. So 2.5, comma, negative 2 with a radius of 4. Okay? But when we were looking at our original equation, well, we couldn't tell what the center and the radius was going to be. Now we can. Okay, so now if we wanted to draw this thing, we could. Okay? All right, hopefully that stuff is making sense. Completing the square, we need to do that often. All right, doesn't quite all fit on the page, but I don't want to make it too much smaller. Let's just take a look at the next problem as it is now. We'll shift the page if we need to. All right, so it says show that the circle with the equation x squared plus y squared plus 20 equals 2 times the quantity 5x minus 2y is congruent to the circle with center 0, 0, it says there, and radius 3. Indicate the translation needed to map the first circle to the second circle. Okay, so it wants us to show that these two things are congruent. Well, what's it mean for two shapes to be congruent? Well, they have the same shape and same size. Okay, well, since these are both circles, they obviously both have the same shape. They're circles. So I just want to show that they're the same size. And if they're the same size, well, then how can I prove that they're the same size? Well, if they're the same size, then their radius, their radii are going to be the same. Okay, so I want to show that each of these have the same size radius. Okay? All right, like it says here, remember the first circle has a center of 0, 0 and a radius of 3, so then I just want to show that this thing also has a radius of 3. Okay, and then once I know where the center is, we can show where it was shifted, because that's kind of what they're asking, if they're the same size, well then how did you get from this circle to this circle? How did you move it? Okay, so anyways, first step, we got to get this thing in descriptive form. All right, now before we can do that, I need to multiply out the right side of my equation here. Okay, so leave the left side alone for now. We got x squared plus y squared plus 20 equals, distribute the 2, we're going to get 10x minus 4y. All right, now let's see, now we want to shift a few things around. I want to get the x term and the y term on the other side of the equation because I need to match, pair those up with the x squared term and the y squared term. So I want to subtract 10x from both sides. I want to add 4y to both sides. And then while we're at it, I would like this number on the other side of the equation. So we're going to also subtract 20 from both sides so we can move some stuff around a bit. Okay? And then when we do that, let's see. I think I can manage my space here. I think we'll take all this stuff and go right up here. Okay? When we do that, we get x squared minus 10x. And then remember, we're going to want to complete the square, so we're going to add something to that to make it a perfect square. So plus blank plus y squared plus 4y plus blank equals, and then on the other side of the equation we got minus 20 and then plus blank because we need to add whatever we added to the left side, we need to also add that to the right side. Okay, so hopefully you're able to fit that on your page. Yeah, there's a little tight here. Okay, next, what's going to go in the blanks? Okay, and again, write it whichever way you want. Half of negative 10 is negative 5. Negative 5 squared is 25. Okay, or you can just write the number. Half of positive 4 is 2. 2 squared is 4. Okay, so it doesn't matter how you write it. It's just your preference. Okay, and then why did we write it like that? Well, now I can write this thing as a perfect square. This is going to be something with x in it squared, and then what goes in with the x? Well, what did we square to get 25? Negative 5, it's right there. Plus, this is going to be something with y in it squared, and what did we square to get 4? Positive 2. And then equals, let's see, negative 20 plus 25 is 5, plus 4 is 9. Okay? All right, so let's see. Yeah, we can write it. We got some space. The center for this circle, we can see now is it going to be at 5 comma negative 2. And my radius is going to be the square root of that number, so square root of 9 we just get 3. Okay, so let's see, are these two are these two circles congruent? Our original circle had a radius of 3, this circle has a radius of 3, and they're both circles. So yeah, same size, same shape, yes, they're congruent. Okay, and then like I said, indicate the translation needed to map the first circle, which is this one, to the second circle. So how do we get from a center of 0, 0 to a center of 5 comma negative 2? Well, we want to shift. We're going to shift right 5. And down 2. Okay? And that's how we get from the first circle to the second circle. Okay? All right, so this stuff's not hard to answer. We can see they're congruent. That's pretty easy. Again, most of the work is just completing the square. All right, let's go ahead and move on to the second page. And get these notes wrapped up. All right, let me zoom out a little bit so we can see everything on the page. Hopefully it's not too small on your screens. All right, remember that warm-up problem we did? It said identify the radius, the center and radius of the circle. X plus 3 quantity squared plus y minus 2 quantity squared equals 100. Okay, so then our center for that was negative 3 comma 2. And the radius is just the square root of that number, so the square root of 100 is 10. All right, we want to make this circle twice as big as it currently is. What would the equation be to accomplish this? Okay, so let's see, what dictates the size of my circle? Well, the radius. And what dictates the radius in our equation? Well, this part. So if I want to make my circle twice as big, do I just double that number? Well, if I double that number, I get 200. Is the square root of 200 twice as big as 10? Well, no, the square root of 200 is not 20. The square root of 200 would be something smaller than 20. Okay. Let's answer the questions they're asking us here. So think, what actually determines the size of a circle? Like we said, the radius does. And how would I dilate a circle with a scale factor of 2, make it twice as large, in other words? Okay, so that might be a weird way of saying it, but what we want to look at is this. I have, let me say it this way. In my equation, I have my radius squared. Okay, we want to make the radius, the circle, twice as big. So then that means I want to double my radius. So then I need in my equation 2 times my radius squared, which is going to result in what? Well, what is 2r squared? Well, that would give me 4r squared. Okay, in other words, if I want to double my radius, well, since I'm squaring that number, it's actually going to make my circle 4 times as big. Okay, so then if I want to make this circle twice as big as it is, I need to multiply this number by 4. Okay, which would give me, well, my center didn't change, it's still x plus 3 squared plus y minus 2 squared equals, and then if I multiply this by 4, I get 400. And then we'll just check that. What's the square root of 400? Well, it's 20, because 20 times 20 gives us 400. And then, yeah, 20 is twice as big as 10, which was my original radius. Okay, so anyways, if I want to double the size of my circle, I actually need to multiply this number by 4. And again, why is it 4? Because I'm doubling my radius, but then I got to square that too. If I wanted to make my circle 3 times as big, if I wanted to do 3 times my radius, well, that 3 squared would turn into 9. I need to make this number 9 times as big to triple the size of my circle. If I wanted to quadruple it, if I wanted to make my circle 4 times as big, well, it's actually 4 squared, so it'd have to make that number 16 times bigger than it is. Okay, so however much bigger you want to make your circle, it's actually going to be that number squared is what you have to multiply this number by. Okay, so hopefully that made some sense. All right, last example. Let's wrap this up here. So example 5, show that the circle with the equation, this thing, is a dilation image of the circle with center at -3, 1 and a radius of 8. What's the ratio of dilation? Okay, so basically what we want to do here is get the radius of this circle here, and then, of course, since it's a dilation and it didn't shift at all, the center should be the same. Okay, and then I just want to compare the old radius to the new radius, and then I'll see how much bigger or smaller my circle got. All right. Okay, let's do it. First thing we want to do, and hopefully you can see this. I know I'm zoomed out kind of far, but I got x times x plus 6. Well, I don't want that in my equation. I want to distribute that x. I've also got y times y minus 2. I want to distribute that because if I'm going to put this in descriptive form, you know, I need to be able to complete the square. I can't do it when I have these products here. Okay. All right, so then let's see. X times x plus 6 gives us x squared plus 6x. And then we're going to want to complete the square, so kind of thinking ahead, I'm going to put a plus blank so we have to write as little as possible. And then we're going to have plus, this is going to give us y squared minus 2y. I'm also going to want to complete the square for the y's, so we'll throw a plus blank in there. And then what's this going to equal? I already got the 134 on the other side of the equation. Good. Sure, it's on the left, but it doesn't matter what side it's on, so I'm just going to switch it to the right. Okay. And then plus blank and plus blank. All right, now we're ready to complete the square. So what's going to go in the blank here? Well, half of that number squared. Again, you can write it as 3 squared, or you can write it as 9, or one of each. Okay, what goes in this blank? Half of that number squared, so you can put it as -1 squared, or -1 squared is just +1. So again, you can write it either way you want. Okay, and then now that I have it written this way, now I can complete the square. I can write this as a perfect square. This is going to be x plus 3 quantity squared, plus this is going to be y minus 1 quantity squared, equals 1 plus 9 is 10, plus 134 is 144. Okay. All right, so now we've got it in descriptive form. Now I can identify my center and my radius for this circle. My center is going to be at -3, +1. And my radius is going to be the square root of that number, which that actually worked out nice. That is a perfect square. The square root of 144 is just 12. Okay. All right. So yeah, we can see that our circle here is just a dilation of this other circle. The centers are the same, so they're in the same spot. They just made one bigger than the other. It had a radius of 8. They made it bigger until it had a radius of 12. And then what is the, what do they call it? The ratio of dilation? Well, it's 8 to 12. We just want to compare the two, the two radii. Okay, and then we just want to reduce that to get our final answer. 4 goes into there twice, goes into there 3 times. So the ratio of dilation is 2 to 3. Okay. All right, and then that wraps up the 7.2 notes.